You type a question, hit enter, and answers instantly appear on your screen. It feels weightless, like pure thought plucked out of thin air. Behind that glowing interface lies a heavy physical cost. Asking a model like GPT-4 to generate a simple 100-word email consumes up to 3 bottles of fresh water just to cool the servers processing the request. The electricity required is even more substantial. This bar chart shows the baseline energy of a standard Google search, which takes a tiny fraction of a watt-hour. When you run a query through ChatGPT instead, the energy required shoots up nearly 10 times. The cloud is a marketing term. In reality, artificial intelligence is an extractive, resource-heavy physical industry built out of concrete, steel, and billions of gallons of water. To process millions of these interactions every hour, tech companies build massive, warehouse-sized data centers packed with specialized hardware. Running and cooling those endless rows of servers requires incredible amounts of power. In 2025, Google's total electricity consumption surged by 37% in a single year, marking the biggest increase in the company's history. That sudden spike is blowing past the industry's own sustainability timelines. Ambitious corporate pledges to reach carbon neutrality are now being quietly delayed or completely derailed. By 2028, AI data centers in the US alone are projected to consume around 300 terawatt-hours of power annually. This map illustrates what that number actually means. It's enough electricity to run 28 million American households for an entire year. Tech companies often pitch artificial intelligence as a tool to solve the climate crisis, but the physical infrastructure required to run it is actively accelerating a global energy shortage. To understand why these systems pull so much power off the grid, we have to look at the 2 distinct phases of an AI model's lifecycle. The first phase is training. This is a massive, one-time expenditure where thousands of processors run continuously for months to ingest data and build the foundation of the model. The second phase is inference. This happens every single time someone actually uses the live model to answer a question or summarize a document. While text generation is demanding, developers are now integrating AI into tools that generate images and video, or create autonomous agents that execute multi-step tasks. These operations require thousands of times more computing power per query than a simple text prompt. As tech giants push these heavy features to billions of consumers, inference stops being a small operational cost. It becomes a compounding, unbreakable baseline of demand on the power grid. The tech industry often argues that hardware is improving and that next-generation AI chips use less electricity to perform a given calculation. That brings up a rule in economics known as the Jevons Paradox. When a technology becomes more efficient, it gets cheaper to use. People end up using it far more often, which drives the total energy consumption even higher than it was before the efficiency gains. Data centers have to stay online 24 hours a day, 7 days a week. Current wind and solar technology simply cannot provide the continuous, uninterrupted baseload power they require. Facing that reality, tech companies are reversing course. They are paying utilities to extend the lifespans of obsolete coal plants and signing contracts to build new natural gas facilities. Some are operating entirely outside standard regulations. In Memphis, Elon Musk's xAI facility set up at least 18 natural gas turbines to run its supercomputer without acquiring the necessary air quality permits. The scramble is so intense that companies like Microsoft have brokered deals to revive dormant infrastructure, including the site of the worst commercial nuclear accident in U.S. history, 3 Mile Island. The rapid rollout of these systems is reversing the broader transition to green energy, tying the future of computing to the dirty infrastructure of the past. This corporate resource grab doesn't stay confined to the tech sector. It directly affects the wallet of every person sharing the grid. To build out the heavy infrastructure needed to supply these new data centers, utilities have to spend billions. State boards in places like Arizona and California are already approving rate hikes, passing those expansion costs directly on to local consumers. While state regulators approve sweeping upgrades to support AI data centers, they reject plans to bring basic electricity to underserved parts of the Navajo Nation. Zoom out, and this local friction becomes a global race. Geopolitical power in the 21st century is increasingly measured in megawatts, where strategic dominance belongs to whichever nation can marshal the raw electricity required to sustain a digital economy. Different nations are taking different paths. The United States is linking tech capital with nuclear and gas. China is deploying heavy coal alongside renewables, and Gulf states are leveraging vast solar projects to brand themselves as exporters of green compute. The digital potential of artificial intelligence is vast, but until we develop new ways to generate clean, abundant power, that potential remains chained to the physical limits of the Earth.